thread. And if you want to make it pretty fast, then you have to work on the things the thread can do in the same time, because you wait for a packet there and you want to send it there, then you again wait, and you have a lot of synchronizing, and this is a lot of work the kernel does on its own for us. In the kernel space, you just hang on your functions in specific sockets and stuff like this, and then they work on their own. You just have to pay attention on shared data, and the rest is so asynchronous that we want to have it. So actually we moved the whole layer 2 implementation into a kernel module, which you can download right now, and you can compile it and load it. And I think a lot of you are familiar with user space daemons, but the kernel space is a bit different, so I will briefly outline the main differences. First of all, there is a new way to configure the routing daemon. We just set up a new directory in the proc file system, where you have the usual files, or well, the usual names we always have. You have gateways files, you have interface, logging, and some other fancy stuff where you can tweak a bit the kernel module. The main difference between a daemon and the module is that the module always resides in the kernel space, and if you want to tell the module now, please start, then you just echo an interface into the interface file, and then the daemon will start to work on that interface, not the daemon, excuse me, the module, of course. You can run the module on several interfaces. You just echo more interfaces into the file, and then the daemon, I'm still in daemon mode. Okay, we are back. We are now in kernel mode. The kernel module will work on the other interfaces as well, and you can deactivate it by just writing nothing into the file. Yeah, can go on. So the logging is a bit special, because in our user space implementation we had a nice Unix socket where you could connect to the various log levels. It's not so easy in the kernel space, but we provided a log level file where you can change the logging. It's similar to what you know about Linux file system access rights management. You can see we have critical, we have warnings, we have notices, and you can activate them by echoing the number or by echoing the names of the logging levels. And you can just read it from the log file, and it's endless read, and the kernel module will add the logging stuff. You see the module was loaded, and then later we changed the log level, and you will find routing information or whatever information you could have been interested in. So, what can we say about kernel development? Oh, a question. Yeah, okay, questions. Down there. Raise your hands again, please.
Why didn't you use a syslog instead of a log file in proc?
Sorry, I did not understand. What did you answer? No.
The log file is stored in the proc file system.
Yes.
But there is a syslog facility in Linux for this kind of stuff, usually.
You mean why didn't we use this file system?
The syslog file.
Syslog. Yeah. Okay, excuse me. Actually, very often we run on embedded devices, and there's not a whole syslog facility around it. It depends on the device, and there's a lot of stuff which is stripped off, and we did not want to spam the dmask output, because if you switch on, for example, the Batman routing level or the other levels, you have a lot of information, and you can fill up hard disks with it in quite a short of time, And that is why we separated it. If you have the critical warnings or the critical information, they are always logged to this log as well. But the other log levels, they are specifically only for Batman, for the two reasons I just mentioned. So there were more questions?
Yeah.
You just mentioned the log in proc. How big is the buffer for storing these log files?
What? How big is what?
I mean, you have to store somehow a buffer somewhere with the latest log, and how big is the buffer? Can you configure?
The buffer is about 8,000 bytes, or 8,192, if you want to know it exactly. Yeah, here's a question.
Haben noch mehr Fragen?
Yeah, so there's basically questions and comments. One comment is, I mean, this dedicated logging system, if you ever intend to merge something like that in the mainline kernel, you know that this is not going to be perceived pretty well. So
I know that. Yeah.
Okay, you're aware of that. The other thing is basically I would be interested in more details about that implementation and whether it's entirely inside kernel space or whether you still have some kind of control part in user space.
No, it's entirely in the kernel space.
Okay, no, I forgot the other question, sorry. Entirely in kernel space. So do you think it makes sense to have this entirely in kernel space? Because usually what people tend to do is to differentiate between the control plane and the data plane. So you have the actual packet forwarding and your neighbor information and that kind of stuff in the kernel, but the control processing, as in the protocol you speak between your nodes in some user space process, which then just updates the neighbor tables and that kind of stuff inside kernel. That's sort of a structure that people would typically choose in the Linux kernel.
Yeah, we did not, maybe we should discuss this later because we did not finish yet. There are more reasons why we do this, and but I can tell a bit about it because you asked. Actually, what we've done now is we just ported the user space daemon into kernel space. We want to do more. Actually, the idea is how can we save even more bandwidth, how can we make it more efficient, and there are several ideas floating around. For example, embedding the hello messages. We broadcast the hello messages directly into the Wi-Fi layer or something, which is broadcasted anyways. Something like that. And that will be more difficult to handle from the user space and, all this forth and back. And there's another point. We always keep in mind, we focus on our users. We have a lot of users in Freifunk, for example. They are not really experts in routing, not experts in, kernel development and stuff like this. They just want a tool, plug it on, and it should work. And if we have 3 tools and 5 configuration files, and this is the harder it is, the more you will scare them away. And if you just have a module and say, load it, and then echo, your interface into the file, and then it works, that is what we want. And we don't have the intention, or not at the moment, to go into the mainline kernel, and so that is not an issue for us.
So. Then I understand this, because it's also this architecture, like being a Linux kernel networking hacker, this architecture with echoing interfaces and proc files and so on, it's you're going to see lots of tension if you ever intend to do something like that. One final last comment or question is regarding the functional principle, because you basically create one large broadcast domain.
One large what?
Broadcast domain. I mean, what I understood is basically you link together your entire mesh network and it appears as one link layer, as one virtual link layer that's sitting next to your interface.
Yes.
Now, I see severe scalability problems with that, given the amount of broadcasting and multicasting that's going on by, you know, zero configuration, Avahi, MDNS, the entire Windows world, and all that one.
Yeah,
I mean, the number of machines that you get in such a virtual broadcast domain, I'd expect to be fairly limited. Do you have any comments or?
Yeah, that's right. I think if you plug thousands of Windows machines into this, it will just blow up because they all broadcasting all the time, hello, I'm here, and so on. This, of course, this might not work, but if you have a big Wi-Fi network with maybe 1,000 of nodes and you have very long hops, you have so much packet loss that it does not make sense anyway. So maybe you can just create smaller meshes and route them again.
Well, yeah,
like as you do with Ethernet segments, you just route them again, but you still can plug them together very easily.
Wait a second. You can you can ask your question in a second. Yeah. Yeah. But this is the question we hear quite often. The scalability issue and the broadcasting issue and all this. Please keep in mind, this is a wireless network, and we have a lot of packet loss. And you could imagine, yes, in a perfect network where every packet, you know, reaches the next hop, and you have 1,000 nodes, then you have a lot of broadcasting by zero configuration and all that kind of stuff. But in a wireless network, as I showed in the beginning, we have a lot of packet loss, really a lot of packet loss. I think this limits the whole issue right from the beginning. But again, we cannot create a tool which relieves the administrators from thinking. You know, we can create a tool which helps them, but you know, we still need some kind of administration. And yeah, I think this will be an issue in the future, but now it's not an issue. Okay.
Could you use EB tables to filter out some traffic that you don't want, or something like this?
EB tables, you mean?
It's bridge table.
Yeah.
It's similar to IP tables, but for bridges.
Yeah. IP tables won't work, and we did not try it with EB tables yet. We are not sure that works, because as it resides in the kernel space, and we hook into special functions. I've not tested it yet, whether the EB tables functions will be called later or before that. So it may be that you cannot filter with EB tables, but we have to test it. Okay?
Is what you need, can you have two separate mesh networks, or do you need to do some extra coding and add sort of an ESSID so that you can tell them apart?
The mesh networks itself, you mean?
Yeah, could I run two separate mesh networks?
You can have two separate mesh networks simply by choosing another channel or another. I mean, you still have the Wi-Fi layer where you can separate the mesh networks. But why would you do that? I mean, it would be, with this technology, it would be even better. Imagine that all the households would use the same technology and bridge together, and then you could create your own IP network on top of it, or whatever technology you want to use.
But the problem there is it's still all one single broadcast domain. And the thing that the other guy raised about 5 minutes ago is that the broadcast traffic, because it has no TTL, it just carries on
we are talking about the
expanding.
future.
Yeah.
So in this future, we could add, you know, special identifiers to only keep the broadcasting in the broadcast domain. But why would you want to separate the networks?
Well, why do we have separate ESSIDs on Wi-Fi networks?
Yeah, good
it's
question.
precisely the same thing.
Yeah, but think it the other way around. If you have, for example, some neighbors between you, and you don't know them or you don't like them or whatever, but you want to talk to the guy behind them, and you could use the same network, because it's not limited by the IP or whatever layer, but you can use them as a bridge. It would be nice, wouldn't it?
So when you do bridging, do you set up your BAT interface, and then if you need to bridge that to an Ethernet interface, do you just use bridge tools and create a BR0 device and add them?
Yeah.
Okay.
Okay. There's another question. Wait for the microphone, please.
Where is it?
I have more of a suggestion for creating different networks on the similar on the same medium. Maybe you could use 102.1q, so you just use VLANs on the lower level interfaces that Batman uses.
Yeah, we already okay. We already discussed
you can keep separate networks around.
Yeah.